Hey guys, since I've already got one Admiral opened up and out on the workbench, I figured I might as well take a look at the other one. This is the one that I just picked up yesterday at an estate sale. So this is an Admiral 20X12 brown Bakelite, and this is an Admiral 20X11 black Bakelite. If you haven't seen it already, I suggest you go back and watch my video on the estate sale where I picked this up, because that's when I first opened up the back and took a look inside. What I'm going to do now is pull the chassis out. I've already taken the knobs off. There should be some bolts on the bottom holding the chassis in place. I'll take those out and then slide it out. I removed 4 bolts that were holding the chassis in and slid it out. Here's a look inside the cabinet. Actually quite clean considering how old it is. Here's the label, 20X11. I think the N at the end refers to the type of tuner that was used. I think there were 3 variations of tuners. And there's the tube chart. Unfortunately, one of the feet is missing below. The one on the back left there. Probably won't be able to find an exact match, so I might be able to just replace all 4, or rather all 3, and then put a new one on there so they're all the same height. Here's a field coil speaker, very good condition, and there was a little scrap of grill cloth in front of it, and if this looks familiar, it's because it's the same cloth I salvaged from that combo set. And it's also used in one of my other Admiral, or several other Admiral sets. So this is the same grill cloth I used in console sets. For some reason they put a little scrap of it on the Bakelite set. You don't really see it because it's mostly obscured by the cabinet on the side here. Well, anyways, here is the chassis. It looks to be virtually corrosion free, which is fantastic. So I'm not in the mood to strip rust off for days again like I am on the other one. So I commented earlier that a lot of these tubes seem to still be Admirals, like almost all of these are. The 6 AU6s in the IF section here. Let's see, does it go back in? Yeah. And although it is stamped Admiral here and has other markings that to me indicate it's the original picture tube, on the base here it says National Video Corp 10BP4. I've come across a few other National Video Corp tubes, and somebody had told me online that this was a company that made replacement picture tubes, but I don't know. Admiral might have outsourced to them. Oh, something else that's kind of odd here is I mentioned before that there's a revision here, R, and if you look around the chassis you'll see there's an R on the focus coils, an R on the yoke, but the picture tube has an S on it. I would have thought that would have been an R. So I don't know, maybe this wasn't the original picture tube. Hard to say, but obviously it's, it does have the Admiral mark on it. Important thing, let's tip this on its side and see what we've got underneath. There we go. Oh, by the way, the radio program you hear in the background, that is Twilight Zone. Every Saturday night from 1 to 3 a.m., AM 560 WIND plays the Twilight Zone radio dramas. These are modern interpretations done from usually the original scripts, but I think some of them are also new scripts. They get some, usually have some pretty good actors, like this one has Malcolm McDowell playing one of the characters. Right away I can see that some work has been done on this set. That's a replacement cap, and that's a replacement cap. What's weird though is that there should be 2 caps here. Originally there was a metal can here with 2 sections in it. It's a dual 40 microfarad at I think 250 volts. That's just a single. So I wonder where the other one is. Strange. I think a lot of these others are replacements too. It's hard to say, but because they're all different brands. You know, like this is one brand, that's another brand, that's another brand, that's another brand, that's another brand. The original ones, I think, is like this. It's the heavily wax-coated yellowy guys, like in here too. So it looks like quite a few probably were replaced, but they were replaced a long time ago. There's the original power resistor. Sand resistor. That's one out that was kind of a crude repair job on the other set. And this just uses a single. The other set had 2 power resistors up here, but this just has one. On the schematic they indicate that that was just a design variation. Some had 2 power resistors, some had 1. It's nice to have the IF shield here. It was missing on another one of my sets. But this is missing. There should be a cover over the tuner here. But it's just a piece of cardboard. And then 2 screws hold it down so I can fabricate a replacement easily enough. Alright, well, I don't see anything anything bad. I mean, I don't see anything that's burned up or exploded or anything. Here's the Sam's Photo Fact service info for this set. I love how Sam's included photographs of the original chassis with part identifiers. So here's that capacitor I was puzzled about. And label it as C3. If you look on the parts list, C3, it's just like I had thought. It's supposed to be a dual section 40 microfarad to 250 volt. So, how can this set only have 1 in there? Well, let's see where it's supposed to be on the schematic. Maybe there's a capacitor hiding somewhere. Alright, here's one. It's used, it's a cathode bypass capacitor on the audio output tube. So, if I just find pin 6 on the audio output tube, there should be a capacitor attached to it. And that is a tube that's up front. I think it's this guy right here. So, there's a white wire, I believe, is pin 6. Maybe it's this guy. Well, I'll have to poke around a little bit more and see where that audio output tube is and try to find pin 6. Actually, I think it might be this guy. Let's see. Yeah, that's it up there, hiding. So it's this guy. So 1, 2, 3, 4, 5, 6. This pin right here. Yep, that's what this guy's going to. So C3, the B section we've got. So where is C3A? That's supposed to be over here. Which can be a little hard to track down because it goes all over the place. Well, I'm going to hunt around on this chassis and see if I can figure out where this capacitor is supposed to be. It took a while, but I did finally track it down, but it doesn't match what's on the schematic. So, if we follow the center lead off the focus coil, the red wire here, goes to the power resistor. The other end of that's supposed to go to that capacitor, which is this orange wire. And if we track that down, it's going to this guy, which is a multi-section can electrolytic capacitor. It's mounted on top of the chassis. And you may notice that there's 4 lugs on it. But if you look on the parts list, it's only got 3 sections, A, B, C. But what I've got is A, B, C, D. So instead of there being C3 and C3A and B, there's just a single section here, but one of these guys is 4 sections. So, isn't that delightful? So, you know, sometimes even when you have all the greatest service info, you really do have to learn how to read schematics and trace wirings and so on, because they were really cranking out a lot of TVs back then. There were a lot of variations, especially on Admirals. So, quite often you cannot just go by the schematic. Huh, that's interesting. I just noticed somebody added a fuse down here. There is supposed to be one over here, but usually it's inside the high voltage cage. So I'm not sure why somebody would have stuck one down here, but hey, never hurts to have more fuses. Crappy soldering job, and that is not a good thing. Well, so I've seen worse, but I've seen better. I was hoping it'd be a little bit more pristine and original considering the rest of the set looks to be, but it's definitely been worked on a bunch. I decided to do something a little bit different with this set than my usual technique, which is to just carpet bomb and replace all the capacitors at once before even trying to power the set up. So what I'm going to do is, first off, took out the rectifier and I want to power it up to see that we get the filaments to light up, meaning the power transformer is good, or at least the filament section of the power transformer is good. But then I'm going to attempt to try a process called reforming capacitors. Some guys have had luck with it. I generally don't even bother because I know I'm going to be replacing them anyways, but I'll give it a try. So what I'm going to do is put a dim bulb tester in series with the power cord and use light bulb wattages starting out at 60, and 75, 100, 150, and then 200, and then move on to just straight full line voltage. And I'll leave it at about 15 minutes at each wattage. What that will do is slowly, or at least what I'll attempt to do is bring the electrolytics back to life. It is possible to chemically reactivate the electrolytics by slowly increasing the voltage rather than shocking it with full voltage. Now, I don't expect the set to work completely right. Assuming anything happens at all. But my thought is, if I can get it to sort of come back to life, what I'll do then is what a real serviceman would have done back in the day, which is to diagnose the fault, like no sound or no picture, and replace those parts first, repair the bad sections first before moving on to other areas. So I've got it plugged in and turn it off for the first time here. Again, I pulled the rectifier tube out, so what I'm hoping to see is tubes light up. Alright, it's on. 6AL5 lit up right away. Now I see some other tubes lighting up, so that's a good sign. So the purpose of me removing the rectifier was that there will be no high voltage going to the set at all. It's just strictly 6.3 volts on the tube filament. That's it. Alright, that's a good sign. Oh, and I already did check the picture tube, and it is good. Alright, so this all seems good. What I'll do next is put the rectifier back in and go through that light bulb. Okay, 5U4 has been reinstalled, and I got a 60-watt light bulb. Of course, you could also do this with Variac, but mine's still on the fritz, so I'll go with light bulbs. Alright, so it's glowing very brightly as it should, because a TV like this draws a lot more current than a radio would, so I'm really starving it of voltage and current. So I'll let this sit for a while and then start increasing the bulb wattages. So far so good. Now I'm up to 150 watt light bulb, which glows much dimmer than the earlier bulbs because it's a lot more current to pass through. Okay, time to try it at full power. Well, it's some light coming out of the speaker. No idea what it's picking up though. Sounds more like a radio station or a TV station. And we do have some life on the picture too. It's channel 6, I believe, which is an actual TV station. I was picking up sound around channel 2, so I'm not sure what that's all about. So, what are the symptoms? Well, it seems to be some reception problems. I should be able to pick up channel 6. And we've got some vertical height issues. Oh, that's channel 6 coming through a little bit. Alright, so we've got some sound issues, and we have a vertical collapse. So let's tackle the vertical part of it first. So vertical output tube right here, it's 12AU7, and use a capacitor, electrolytic capacitor on the vertical output, this guy right here. 100 microfarad on the cathode. So my first guess is that that capacitor is leaky. I'll also check the 12AU7 and the associated resistors and capacitors too. Let's see if we can get that working first. I turned the set off and then checked each of the multi-section electrolytic cans, and this one is cold, but this one's actually warm. That means I've got some excessive leakage current in this guy, so I think I'd better bypass it. It's the main filter cap right off this tube. There's an 80 microfarad, and then the field coil, and I think a 40 microfarad, so I'm going to tack in some modern electrolytics and bypass this guy. The last thing I want is for this to overheat and rupture. I did a little research online and found this chassis in Riders Volume 4. There's an interesting note here about Production Run 5. Apparently sets earlier than Production Run 5 did use a 4-section electrolytic and then a single 40 microfarad electrolytic, which is exactly what I see in my set. So I thought that I might have a later production run. It turns out I actually have an early production run. So here's what the original capacitors were, and here's how they were hooked up. So it's very nice to have a confirmation that what I'm seeing in mine is actually the original component values and it is correct. Before I start replacing capacitors, I thought it would be interesting to actually test them first. For example, that electrolytic capacitor that was just getting warm has 3 sections in it, and I'd like to see if all 3 sections are bad or just one of them or 2 of them. And I can do that with a device like this, but before I can use it, I need to actually recap this, because this is full of vintage original capacitors, including a couple electrolytics. This is a Solar CB-1-60. Pretty neat little device. Uses a type IV rectifier. It's just a half-wave rectifier, and a 6E5 output, or sorry, 6E5I tube as an indicator. It works on a bridge, So you rotate this control to get the maximum eye opening, and you read the values off this dial. You can measure both capacitance and resistance and test for leakage up to about 500 volts. So very nice for testing these old caps, which are typically rated upwards of 500 volts. A little pocket modern digital capacitance meter is not going to really test a capacitor properly. It's not going to put anywhere near this much voltage on them, which you really want to do to see if you've got any leakage current. I do have the manual, and it has a schematic in it, but it's just one problem. There are no values on the schematic. However, I do recall seeing on the antique radio format someone had gone through and filled in these values. Otherwise, I can try to read them off the capacitors, but... oh, there we go. 4 microfarad, 450 volts. I've got a bunch of 4.7 microfarad at 450 volts, so that should be close enough. And as for these, let's see, 0.5, 200, I got one of those. And this big guy here looks like 2 microfarad at 100 volts. I think I have something for that too. I'll go through and check the resistors as well. I finished the recap and also replaced a few out of spec resistors. I had to double up some parts here and there, like here's 2 resistors in series and a couple capacitors in parallel, because there's some oddball values in this. And also, technically, this, and this capacitor should be 2% precision types, but I used 5 and 10%. That's all I had on hand, so I expect the dial may be off a little bit, but really am more interested in testing for leakage. So I'll flip this down and let's give it a try. When I first powered this up, it still wasn't working right. The neon light was never lighting up. Then I took a closer look at the bulb, and unfortunately it was cracked. That's a real shame because these are hard to come by. I ended up rating one from my B&K 440 CRT tester, which has 3 of them in it. I'll hunt around for a replacement eventually. So I've got it set up to measure capacitance, and I've got it hooked on the very first filter capacitor here right off the rectifier. Now it's rated at 80 microfarad, and this is only measures up to 70, but I notice that I can still get a reading on it. You rotate this dial for maximum deflection, and I get it right at the end of the scale. So assuming this is calibrated accurately, yeah, it's measuring around 70 microfarads or so, which is good. Now for leakage, supposed to have this rotated completely clockwise, and then you go through these ranges: 0 volts, 100 volts, 200, 300, 400, 500 volts. This light is supposed to light up as you go through each range and then fade away. That's the capacitor charging up and then discharging. So it tests both that it can hold a charge and that it doesn't have leakage. So, lit up, faded away. 200. Lights up, but it's taking a lot longer to fade. 300. Taking a lot longer to fade. I looked in the instructions and they said that it could take upwards of a minute or longer if the capacitor hasn't been used in months or years. And they also explained the reforming process. Well, I've already had this running a couple hours at slowly incrementing voltages, so if it was going to reform, I would have thought it would have reformed by now. So I suspect this is the culprit, or at least one of the culprits for the capacitor getting warm. To eventually go out there. Let's try 400. This section is rated for 450 volts, so I will not go up to the 500 point. Alright, it took about 45 seconds, but the light did go out, so there's still some hope for this section of the capacitor. It does have some capacitance, and it has a little bit of leakage, but not too bad. Now, let's check the next section. See how that light went on when I put it on 0? When you put it on one of these ranges, what it's doing is it's charging up the capacitor. And if it's leaky, it's going to take a while for it to fully charge up because charge is draining off as you're trying to charge it up. So you do not want to reach over and grab this lead or you will get a nice shock. That's why they have the 0 position. Always put it back on 0 to discharge your capacitor before you go grabbing any leads. Something else I should point out is that I did unsolder some of the connections going to this. Now this section, the only wire going to it just goes to a socket that goes to the field coil on the speaker, which I have disconnected, so essentially there are no other components attached to this. This one there were, but I unsoldered the lead, so right now it is completely out of the circuit. You can't really test the capacitor while it's hooked up to other stuff because it will affect the readings. Now this section is the 40 microfarad cap on the other side of that field coil, which is acting as a filter choke. And 40 microfarads is well within the range of this device, so I should definitely get a reading when I measure the capacitance, assuming it's good. Alright. Well, that's not a good sign. There's a 40 mark, so I should be getting an eye deflection right around there. And I'm getting nothing. Nothing until I get over here, which is open. So it sure looks to me like this section is completely open. There's 3 ways an electrolytic capacitor can fail. It can be open, as in this case. Typically happens when the electrolyte dries out. It can be dead short, or it can be leaky. So it looks like one section is a little bit leaky. This section is completely open. And just for the heck of it, let's try checking the leakage. Remember, that light should flash on momentarily, then fade away, and nothing. So this section is completely dead. There's one more section here, which is another filter cap on either side of the focus coil, so let's check that one. Alright, that final section is 20 microfarads, so it should be somewhere around here on the scale. Let's see. Alright, got eye deflection, that's good. Maximum, right about that. Alright, so it's not too far off of 20. So let's check for the leakage. You're supposed to have this fully clockwise when you do that. This is taking a lot longer to fade away than that first 80 microfarad section did, so this one is even leakier. This one could definitely be accounting for the capacitor getting warm. This is also rated for 450, so I should be able to get all the way up there, but it's not even being able to charge up to 200 volts. So, it seems to me I could probably leave the 80 section in there, but the 40 has got to be replaced because it's open, and this one seems to be pretty darn leaky. Might form up eventually if I keep it running, but I think I'll just go ahead and replace it too. Okay, I've tacked in a replacement for the bad 40 microfarad section and the bad 20 microfarad section. So just temporary, just to get the set running. So let's give this a try. Oh, that's better. Before we just had an image that was about an inch high. Now it's covering a good chunk of the screen. So the centering could be off because of some controls on the neck here. You can adjust these screws to move the picture up and down. You put a screwdriver in there and there's spring tension and it manipulates this focus coil. Or it could just be a matter of adjusting the vertical height and linearity. Let's see, those are these two here. This is height. Oh, it's all the way to the right. It's not really having much of an effect. Well, this control is completely frozen. The linearity control. Oh, man. Oh, there we go. Boy, that's completely seized up. Well, not having a huge effect. Alright, so possibly we need to look at some more of the components on the vertical. So getting back to this, that's that 12AU7 and checking this electrolytic here. And also, still don't have any sound or video. This does use inter-carrier sound, meaning that the sound and the video go through the IF stages together. So, comes out of the tuner mixer here and goes through all these stages. And then the audio is picked off right here on the plate of the video amp. It goes over here, this little 2 picofarad cap into the sound stages. So if anything's wrong in here, you lose both sound and picture. Now, fortunately, there's a whole lot of stuff in there. If we're lucky, it's just a bad tube. If we're not, well, it could be any one of many of these components. But first, let's get a more stable picture, get full vertical height. Then I can use my B&K 1077 TV analyst to inject test signals at various points, starting at the video amp and working our way back. And we'll find out, hopefully, at which stage we lose picture and sound. I've now moved on to checking this 20 microfarad capacitor that's on the primary of the vertical output transformer. That drives the vertical deflection coils. That makes the beam sweep up and down. It's one of the 4 sections on this multi-sectional electrolytic down here. I've already unsoldered the wires that were going to it and clipped on my capacitor tester. And let's see, it's supposed to be 20 microfarads, so we should get an open eye somewhere around here. And nothing. No eye deflection or opening whatsoever. If I go all the way back over the other way, the eye does finally open when I'm here in the open section. So just like before with that 40 microfarad filter cap, this cap is completely open. No amount of reforming attempts are going to help that. It's dead. So I've got a replacement here ready to go in. This should have a noticeable effect on that vertical. So maybe we'll get a full raster now on the screen. A new 22 microfarad cap to replace that open one. And I also went ahead and installed a new 100 microfarad cap. My capacitor tester won't measure that high of a capacitance. That's the cathode bypass capacitor on the vertical output tube. Unfortunately, after doing all that, I now have no picture, so fix one section, something else breaks. But I found something else out. So, earlier on I was getting little bits of sound now and then. I found out that's because the tuner is filthy. There's silver-plated contacts down in here, and some of them are not making good contact inside the tuner up here. And when that happens, the oscillator and mixer don't work right. So if I go back and forth a bit and clean these contacts up, I'm not getting some sound. So I'm making some progress. And that comes out again. I'm going to clean up these contacts. They number all the sections here, so that was channel 6 we were listening to, and that's the here, and you can see how dirty those silver contacts are. So I'll get those cleaned up good, which should help out on the tuning. And I'll get on my high voltage probe, and let's see if we have indeed lost high voltage to the picture too. I took a small rag and some metal polish and polished up all those silver contacts for channel 6. It's a lot better now. You could also spray something like deoxit in there, but why? I figure why spray all that fluid in here when you can just so easily access these and polish them up by hand. This definitely helps. So now it tunes in, but it sounds horrible. It has a horrible buzz. I can think of two reasons for that. One, there's a 4 microfarad electrolytic on the ratio detector. And two, there's a 60 microfarad cap, cathode bypass on the 6AS5 audio output tube. If either one or both of those are leaky, that'll cause some problems. The 4 microfarad is this yellow guy up in here. Looks like it's the original. And the 60 is another section on this guy down in here. So now we have some reception, but it sounds terrible, and we've lost the picture. So, audio, I will check out those 2 capacitors, and for the high voltage, I'll flip this chassis down and take a high voltage probe and see what we've got. I installed 2 new caps, so time for another test. Oh, good sound already. Much louder. I don't know that it sounds any better, but certainly louder. So I got it all the way down right now. Just up a bit. Alright, so still some work to do on the sound. Now, how about that high voltage? I took the cover off and hooked up a cheater cord. Let's see. 6BG6 output tube is glowing, but I do not see any glow in the 1X2 rectifier, which doesn't surprise me, because the filament for the high voltage rectifier is powered from a winding through the flyback. So if there's no horizontal oscillation driving this tube to go through the flyback, there won't be any filament glow on the high voltage rectifier. That's horizontal oscillator down there, I do believe, and it looks like it's glowing, but I have not tested it. That could be bad. BG6 horizontal output tube could also be bad. Or any one of a number of capacitors and resistors could be bad, but first I'm going to check the tubes. That's the easy thing to do. I first tested the 6SN7 horizontal oscillator tube and the 6BG6 horizontal output tube, and these both test okay. Not like new, but definitely in the green region. But I went ahead and replaced them with some that I know are good, just to be on the safe side. So here's the 6SN7, sits in this little spring-mounted socket. I think that's to isolate any chassis oscillations from getting in here. And here's the 6BG6 horizontal output tube that I put in there. And then I figured, since I'm testing tubes, I might as well test these as well, and they all tested good, except for this guy, 6AL5 dual rectifier. So it's two sections. Right now I've got it set up to test one section. Test good. Check out this other section. 7 down 4. Oh, it's the same good section again. Up 2 down 4 5. Dead. So there's definitely one source of problem. Half of this tube is completely shot. And now I can see that I look close, there should be two filaments glowing, and there's only one. So, I'm not sure which one is which anymore, but one of these is definitely used in the ratio detector for the FM sound. The other one is used for the video rectifier. I pulled all these out and tested them, and then I put them back in, so I'm not sure which was which. One goes here, one goes here. This is definitely the sound tube, but I can't tell which one was in here originally. So, we'll see. Unfortunately, I can't tell if that was definitely the sound tube. I wish I knew. But I suppose, hey, if the sound starts working really good now, we can just assume that that was definitely the ratio detector tube. Alright, here we go. Oh, definitely a static. Nice clean static, no hum. But of course we also have no sound. Loose tube. That's the 6J6 mixer oscillator tube. Alright, we've got nice clean sound there.
You can also qualify to win a pair of front row seats from Chicago's smooth 87.7.
Before Allegra, my sister and I really suffered with our allergies. My old medicine.
But no picture, no high voltage, so we still got to work on that.
Drowsy relief.
But hey, we've got good sound, so definitely making some good progress here.